In this lecture, we're going to see how to register your own types that you can instantiate on the QML side. The way you expose your data is really not that different from what we've been doing so far. You have to create a C++ class. The class has to inherit QObject. You have to have the QObject macro. You also have the option to expose your properties using the QProperty mechanism. The only thing that changes here is that you don't use setContextProperty or setContextObject like we have been doing so far, and you use another method that is called QMLRegisterType. This is one way to register your type. We're going to see many others, but in this case, you can expose the counter class. Counter is our own custom C++ class that we are exposing to QML. You have to pass in a few parameters. You have to pass in a string that identifies the library or the module that contains the class. You have to pass in a major version, a minor version, and you have to pass in the string that you are going to use to instantiate that object in QML. This is really all you have to do on the C++ side. You define your class and then you expose it like this. On the Qt side, you have to import your module. And you see the name we used here, QMLCounter 1.0, is what we used to register the type, QMLCounter. And 1 is the major version and 0 is the minor version. You have to import like this, and then you can instantiate your counter like this. I know this might not make sense yet. We're going to go to Qt Creator and show you how to use this exactly. Okay, here we are in Qt Creator. We are going to create our project. It's a Qt Quick application as usual. We call it custom types counter demo. Store it in a location on our drive. We choose our Qt version. We choose our kit and finish. The first thing we want to do is to create our counter class. Let's do that. Counter. It's going to inherit QObject. And now that we have the class, we are going to create a bunch of properties. We're going to say QProperty here. It is going to be an integer, the first one, and it's going to say count. We're going to put in a second property. It's going to be a bool, and it's going to say up. It's going to store whether we are counting up or down. We want to generate the methods we need for this to work. Let's generate a getter, a setter, and a signal here. We do the same for up. We want to refactor this a little bit. We're going to move the definitions to the CPP file. Let's refactor and move to CPP. Everything, set up, move to CPP. Up, move to CPP, and count, move to CPP. The other thing we want to do in the header file is to get rid of the public slots here because we want to make these methods public methods. We don't want them to be slots. Control A, Control I to align and remove this. We want to take these fields here and move them down below in a private section of the class. Control A, Control I to align. Now we have our class and it has a few properties. Count, which is an integer, and up, which is a bool. And this up boolean is going to store whether we are counting up or down. Now to make this thing a counter, we need to include QTimer. We need to create a field for timer. And we need to initialize these things in the CPP file. We are going to use initializer lists, and the order is going to be count up and timer. Count up and timer. mCount is going to start at 0. Up is going to start being true. We want to count upwards by default, and mTimer is going to be initialized to a new timer. and the parent is going to be this thing here. We want to set the interval to the timer. Let's make it 500 milliseconds. And we want to connect to the timer and know whenever it times out. We're going to say connect mtimer, pound symbol, qtimer, timeout. We're going to use a lambda function. Let's capture everything and put in our body. Let's close this with a semicolon. And if we are counting up, we are going to increment the count. If it's not the case, we are going to decrement that. Okay, now we have our timer. The other thing we need to do is to provide methods that we can call on this thing to start and stop the timer. These are going to be public methods, so we can say helper methods. They are going to be QInvocables. And another QInvocable. They're not going to be complicated. They are very, very simple. Let's implement stop. And all they really are doing, start is starting the timer. And stop is stopping the timer. Just like this. Now we have the class. We need to expose it to QTQuick. We're going to go to main CPP here. We want to include our class. So let's say include counter and register our class for using QTQuick using this syntax here. We're going to say QML register type. We're going to pass in the type to be counter. We are going to say QMLCounter. This is the name identifier for your library. We're going to pass in a major version, a minor version, and the name that we are going to use in QTQuick to call this. And this is really how you register your type to be used in QTQuick and even be instantiated. Now that we have this, we can go back to QTQuick. Let's change the title here. We want to import our new library, the custom one. It's going to be QMLCounter. The version is going to be 1.0, and you see that it is recognizable. Now we can say counter, and you see that it is recognized as a type. To show you that this is actually instantiated, we're going to go back to our counter CPP, and we are going to put in a debug statement to say that we constructed an instance of counter here. Let's include qdebug for that to work. And say qdebug here. Okay, let's build to see that we have no boo-boos. The build is fine. Let's run the application. Created a counter instance, but we see nothing in here. What we want to do is go back to main QML and put in a rectangle that is going to display the count that we have in the counter. The counter itself is not a visual type, but we can read its data and display that in a rectangle or in a text component. We're going to do that. Let's put in a column component. It is going to be centered in the parent, and we want a spacing of 10 by default here. We want to put in a rectangle component. Width is going to be 200. Height is going to be 200. Radius is going to be 20 by default. We want the color to depend on whether or not the count in the counter here is greater or less than 0. We're going to give it an ID, the counter here. We're going to call it mCounter. And we are going to use a ternary operator. We're going to say mCounter, count, greater or equal to 0. If that's the case, the color is going to be green. Let's move this column to the right. Otherwise, it's going to be red. This is what this says here. If this is true, the color is going to be green. If this is false, it's going to be red. Inside, we want to put a text component. ID is going to be mText. The text is going to be the count in the counter, and we're going to say mCounter count. It's going to be centered in the parent. We want a bigger font. Let's make it 20. And we want the color of the text to be white. Now we want to put in a few buttons. Let's import Qt Quick Controls. We go down below again, below the rectangle, and we put in the first button. The width is going to be 200. The text is going to be start. And when it's clicked, unclicked, we want to do mCounter start. We also want to put in a stop button. And it's going to say stop, and it's going to call the stop method on our counter here. Let's build. And if the build is successful, we're going to run this and see if it actually works. Okay, we have our rectangle here. We have a start button and a stop button. Let's click on the start button and see that we are counting and nothing is happening. Why is that? Why is that? Let's debug this. QML is not being updated because when we change the count, we are not emitting the signal that the count changed here. Okay, this is our problem. So we should come back here in the body of our Lambda function. And at the end, we're going to say emit count changed. And we're going to pass in the current value of the count. And this should do it. Let's run the application. Start. And you see that we are counting. I don't like the text here. It's very small. Let's go back to QML and make it a little bit bigger. For the rectangle, the text inside the rectangle, we can actually make it 40. Why not? This is better. Start 1, 2, 3 and stop. It stops. You start again. It keeps counting. Now I want you to notice that when we forgot to emit this signal, the count wasn't being updated. We were actually counting here, but the changes from C++ were not being propagated to Qt Quick. So you really should always emit the changed signal whenever the value changes in your C++ code. This is very, very important for property bindings to work correctly. Now that we can control the start and the stopping of our counter, we also want to be able to control whether it is counting up or down. We're going to go back to Qt Quick and put in 2 buttons. And we are going to paste this in. This is going to say up. And we are going to say mCounter up. We're going to set this to true. And we copy again, paste it in. We're going to say down. And up is going to be false in this case. When we count down, up is going to be false. And if we run the application, we should be able to control whether we are counting up or down. We have the buttons. So let's start again. 1, 2, 3. If we go down, you see we are going down. And when we cross 0, the rectangle becomes red. because that's the behavior we programmed in here. And ladies and gentlemen, this is how you define your own type to be instantiable in Qt. You see, our counter item here is being controlled by the class that we defined in here. And we are being able to instantiate it because we exposed it like this by using QML register type. And if you want to know more about this method, you can select it like this. Hit F1, you're going to be taken in the help mode, and you are going to read more about it. It basically allows you to expose your C++ data in Qt in a way that you can instantiate the method. You see the examples that they give you here. It basically is exactly what we did here. This is all for this lecture. I hope you enjoyed the capability of being able to expose your data in Qt this way. In the next lecture, we're going to see how to define your own enums in C++ and expose the data to be visible and usable in Qt. I'll see you in the next lecture.